Hello, Hopewell. This is Mr. Steinberg. Today's lesson is all about ellipses. We have these pictures on the page that look like ovals, and I will explain what is an ellipse, why it is a conic section. So let's take our cone. That cone has a circle for a base, and it's some sort of three-dimensional triangle, something like that. What happens is if we intersect this cone with a plane parallel to the base, we found that it makes a conic section that's a circle. Okay? If we intersect this cone at any sort of other angle that's not parallel to that base, the intersection of that plane will form this oval shape, which we call an ellipse. So when it's at an angle, it forms an ellipse. So my goals for you for today, we're going to identify the characteristics of the ellipse, we're going to graph it and make equations for them. There's a lot of vocabulary words, so let's get right in it. I'm just going to do a little bit of a fake simulation with you. Let's say we had a pin and a bulletin board, like a thumbtack, and we tied a string to it. And we put like a piece of paper underneath it and a pencil attached to the string. If we had one stationary point and we stretched the string all the way around, it would make like a uniform circle, right? What if we had two push pins and a piece of string, and we took our pencil and we tried to rotate it as far in each direction? What would happen is if we tied each end of that string to a different thumbtack or push pin and we tied a pencil to it, that would create a shape that is an ellipse. There are lots of different simulations that are out there on the internet for this, and I might attach one in a bonus video, so be on the lookout for that. It would stretch a little bit farther in one direction versus the other. Look at this, the two now it says this is a focus and this is a focus. What do we call the plural of focus? We call it foci. It's also pronounced foci. I always pronounce foci. That's just my preference, but both are correct. So these two foci are horizontal with respect to each other. So the graph of the ellipse can go a little bit farther in the horizontal direction than it can in this vertical direction. We would call in this shape, in this ellipse, we would call the end from one side to the other horizontally, we would call that the major axis. So what is the definition of our major axis up here? It says it's a segment connecting the two vertices and contains the two foci. So what are the vertices? Now the vertices are the endpoints of the major axis. So we have this definition that goes sort of like in a loop. So we're going to have vertices at the ends of the major axis of an ellipse. The major axis contains the two foci and the vertices, and also a point that's somewhere in the middle. On the other direction, this vertical axis, we would call that one, in this case, the minor axis. It's the shorter of the two axes, and they would contain the endpoints of that minor axis. We'll call these co-vertices. The one point that I didn't explain about is we also do have a center of an ellipse. The center is always halfway between the two foci. Let's call that little c. It's always halfway between the two foci, halfway or the midpoint of the major axis. It's also the midpoint of the minor axis. We would call that point C, or the center. Sometimes you have an ellipse that's horizontal and that's wider. Sometimes you have an ellipse that's taller. Now there are two equations down here. On my page it's a little bit light, but on my page it says x squared divided by a squared plus y squared over b squared equals 1. And then they have this x squared over b squared plus y squared over a squared equals 1. So I tend to believe that there's really like one formula for an ellipse, but it's really like an x squared plus a y squared equals 1. The only difference is in both of these is if a squared is underneath the x, or if a squared is underneath the y. That changes the shape. So then why does this give two different pictures? It's this note right here. So I believe there's really one formula. They write it as 2. It says here, note, the value of a is always larger than the value of b, and it determines whether the ellipse is wider or taller. So I'm thinking back to what we learned about circles. Circles was like x squared plus y squared equals radius squared. Now this does not equal radius squared, it equals 1. If we cleared the fractions and multiplied through by a squared b squared, we would get a different equation. We get like b squared x squared plus a squared y squared equals a squared b squared. So it's sort of like a circle formula, except this is what happens if you stretch the circle longer in one direction compared to another. If we stretch our circle vertically more than we do horizontally, it would make a taller ellipse, and so on and so forth. So the reason we get two different pictures and two different formulas is the a squared is always underneath the larger axis. So when I have an a squared underneath the x, that means it's wider. When the a squared is underneath the y, that means it's taller. So what I tell you is this. I would just say that there's one different formula. That the one formula I would just remember is x squared over a constant squared plus y squared over a constant squared equals 1. And a squared is always, the longer one. So getting down to here, I'm not going to totally abandon the fact that there are two different equations, because it's important to notice the difference on whether your ellipse is wider or it's taller. But just notice, it's still x squared plus y squared. Nothing changes. The a squared, if it's underneath the x, that means you have a wider ellipse. And if a squared is under the y, that means you have a taller ellipse. Okay? Now, if a squared and b squared were the same, guess what your ellipse does? It's not wider or taller in either direction. That's what makes it a circle. All right. So I'm not going to really take much notes on the front page. I actually kind of think we're most of the way done, except for this one formula that's down here. This is how you identify where the foci are located. So it says the major, I'm going to read this to you, the major and the minor axes are lengths of 2 times a and 2 times b respectively. All right, so what does that mean? I think you could still see this at the top. That from your center, in this case 0, 0, if you square root the a squared, that tells you the length of a. Go from the center in the x direction, because a is underneath your x. Go a units to the right and a units to the left. This is how you find your vertices. If it's a to the right and a to the left, the major axis has a length of 2 times a. Similarly, if you square root b squared, you get b. That tells you the length of half your minor axis. You would go b units up and b units down from your center. This would have a length of 2 times b. So how do you find the foci? So the foci of an ellipse lie on the major axis at a distance of c units away from the center, where c squared equals a squared minus b squared. Okay, so this is important because why? This is what tells you how to find the two foci. Also, this only works if a is larger than b. If b is somehow larger than a, and we subtract that from a squared, a b squared from a squared, you get a negative number, and c squared can never be negative. So this is the one formula that will be used on either of these ellipses to find where the location of your foci are. Once you find the value of c by square rooting this, then if you have a wider ellipse, you just go c units to the right of your center and c units to the left of your center. What makes sense is that there is a minus here, because you don't want to add a squared and b squared. You don't want to add the square of this length plus the square of that length. That would put the focus somewhere outside of the ellipse. So you want to find the difference of their squares. And that's what tells you how far away from the center. What tells you why they go right and left instead of up or down? Well, the orientation. If it is wider, then your foci will go left and right. If your ellipse is taller, then your foci goes up and down, because your foci are always on your major axis. Getting towards the end at the bottom of this page, there's one numerical example that we can take a look at. So it says, identify the characteristics of the ellipse with the following equation. Now, I'm not even sure why they know it's an ellipse. I do think that it could either be an ellipse or a circle. From what I know, parabolas only have an x squared or a y squared, not both. So look at your coefficients, 25 and 4. They are not the same. An ellipse equation always has a 1 at the very end. So let's divide everything through by 100. And lo and behold, that's what's on our next line on the page. X squared over 4 plus y squared over 25 equals 1. Now what do you notice is the 25 is the value of a squared because it's larger. So if a squared equals 25, that means the length of a, or the value of a, would be 5. So 5 units above and below the center would be our vertices. 4 would be the value of b squared. The value of b would equal positive 2. Notice that I'm not even talking about plus or minus this time because these are lengths. So 2 units in the x direction, 2 units left and 2 units right, would be the co-vertices. If you're trying to find the location of your foci, I know through doing a sketch that it's going to be above and below the center. Now I could tell you why it's 0, 0. Maybe you figured this out already. There's nothing next to your x and y to shift it. So this just says pretty much what we talked about, our values of a and b. And if our center is 0, 0, we're going to go 5 units in the y direction, 5 units above and 5 units below, and that's what makes our vertices. So 0, 5 and 0, -5. These would be the location of your vertices. We would go 2 units to the right and 2 units to the left of 0, 0, -2, 0, and +2, 0. These would be your co-vertices. The length of your major axis is 10. The length of your minor axis is 4. Now to find the foci. Using your formula, c squared equals a squared minus b squared. Plug in your values for a squared and b squared. So c squared equals 25 minus 4. So if c squared equals 21, then c equals plus or minus the square root of 21. Now hang on. How come now I'm doing plus or minus for the square root of 21? Because I'm inside of a coordinate plane. It's not representing a length away from a center. I mean, it kind of is. But I can go up root 21, I can go down root 21 from the y coordinate of the center. The y coordinate in this exercise was 0, so I can go root 21 above 0, I can go root 21 below 0, and these are the locations of our foci. Please continue to our next video.